Hello again, welcome back. Nice job clicking on the video again. Video lecture 12. Got two videos for this one. First, we're going to talk about one more property, one more rule for exponents. And then the next video, the second video, is just going to be about kind of working through several examples, some of the more complicated examples, okay? Applying all of the rules. So to talk about this first one, we're going to talk about a power rule. That's what we're going to be looking for in our ALEKS homework this time. So the power rule, just to give you an example of what we might be looking at, so that we might say, like, if I had 2 to the third and I raise that to the power of 2, so it's power raised to another power. So let's rewrite this, try to get down to what it's meaning. So, and then see if we can notice any patterns that lead us to the rule. So 2 to the third squared, right? Squaring something means multiplying by itself. So that would be 2 to the third times 2 to the third. All right. And what we've actually done is we've turned this into a product rule, right? We're multiplying things with like bases. We know that when it's like bases, we get to add. So we would get to do 3 plus 3 in this situation, or 6. Okay. And if we look back at what we originally started with, we started out with 2 to the third raised to the second power. What is the relationship between 3 and 2 and what we ended up with, which is 6? If I multiply 3 times 2, I get to a 6. So that is the power rule. If I have a base raised to a power and then it's being raised to another power, and that I get to take the exponents and multiply them. Okay, to formally write that, if I have a to the m and then I raise it to the nth power, I get to simplify this a little bit by multiplying those two numbers. Okay, so let's look at how some of this shakes out. We'll use some of our other properties as well. So the first one we're going to talk about is if I had the quantity of 3x squared y all raised to the third power. Okay, so the power rule just helps us to save time, right? To raise something to the third power means that I could write this thing 3 times. What we can also do is kind of think about this as getting quote unquote distributed to each base. So let's look at what we've got. We've got a coefficient of 3. And that 3, right, if we were to write it out, it would be 3 times 3 times 3. We need to make sure that we do that. That is not we're not going to use the power rule for that. It's a coefficient, okay? So 3 times 3 times 3. So we need 3 to the third power. So that would give us 27. All right. One of the most common errors that students will make here is writing down a 9. Because they will take this coefficient and multiply by 3. But you have to recognize that this coefficient, this number, is getting raised to the third power. The power rule only works for exponents. All right, next piece, we've got x squared raised to the third. So x squared times x squared times x squared. We can just do this 2 times 3, kind of like what we saw in our example above. We're going to get x to the 6th. And then lastly, we have a y. It's y to the first. And it's going to get raised to the third power. So y times y times y. We've got a 1 as our exponent here. 1 times 3 leaves us with a 3. Okay, I'm just writing this all in one color. No zero exponents, no negative exponents, so we're good here. Okay, let's try another one. Quantity of negative 2x squared y to the third all squared. Okay, so if you would like to, pause this, try it, come back, okay? All right, we got square, we're gonna square stuff, so right, multiplying by itself. So we're going to go to the coefficient, it's a negative 2. We're gonna do negative 2 times negative 2, which is a positive 4. We're gonna do x squared squared, x squared times x squared, or we just get to do this 2 times a 2. We should end up with x to the 4th. And then moving on to our last, we've got y to the third squared. If we wanted to write it out, y cubed times y cubed. we get a 3 times a 2, we get a 6 as our exponent for that one. No negative exponents, no zero exponents. That's a good final answer right there, okay? All right. Last one here. Let's do the quantity of 3x squared y to the negative third to the negative second power. Okay. So a few things to talk about here, namely the fact that our power rule for this one, right? We have a -2 has this kind of this thing that would need distributed to do the power rule, okay? Now, it's kind of combining two rules at once. We have a negative and we have a power, okay? This something that helps me out, and my greatest suggestion to folks is I look at these separately. I consider the negative first, and then I consider the power rule, okay? I find that to be helpful to just do one rule at a time, so that way we accidentally don't miss a thing, okay? So what I'm going to do, and I do this every time I have a negative exponent getting applied to everything, right? That's important here. This -2 goes to everything. So I know that this negative portion, just the negative portion means that this whole thing needs to be division, okay? So what I'm going to do is, if that negative applies to everything, everything right now is kind of like an enumerator, right? It's all divided by 1. I need to do the inverse. I need to flip this thing and make it division. So what I'm going to do is I'm going to rewrite everything exactly how it is, except for that -2 exponent. I'm going to make it's now a +2 because I've done the division that it's representing, okay? It's the inverse now. So everything else stays the same. I've taken care of that negative exponent, okay? So I prefer to do it this way. Now I go and I work on applying that 2 now, do my power rule. So let's go through there. This 2, right, means squared. So we're going to do 3 squared. 3 times 3 is a 9. Moving on, we have x squared squared. So we get to do 2 times 2, we get x to the 4th. And then our last bit there, we've got y to the -3rd squared. So we're going to do -3 times 2. So we get y to the -6. All right. We make a pass. We ask ourselves, does anything need adjusted? In this case, yes, it does. We have a negative exponent currently. That cannot be in our final answer. So that negative exponent is representing kind of like we need to make sure we do the inverse of what it is right now, where it's at. So right now that y to the -6 is in the denominator. That y base needs moved to our numerator. It will be written as a positive exponent. So y to the 6th. This 9 does not have a negative exponent, so it can stay. The x to the 4th does not have a negative exponent, so it stays, okay? I did not need to write that 1 up top, right? It's just 1 times y to the 6th. So this is a good final answer. All right, good. Again, go straight to your homework, give some of these a try. We're trying out the power rule, okay? I'll see you back for one more video. Take care.